Hey everybody, it's Roger. So we're picking up in this video to talk through the getting started instructions for the Terraform Azure RM VM DevOps configuration. So this configuration is a little bit different from the rest of the Azure Sandbox because the way that we do bootstrapping of this configuration is done uh, not using the Windows subsystem for Linux. And the reason for that is since the developer virtual machines themselves are Windows virtual machines, it's kind of assumed that the organizations that will be running this are Windows shops and may be a little reluctant to install the Windows subsystem for Linux. So there is no WSL dependency for this configuration because all the bootstrapping is done using PowerShell. So the first thing getting started says to do is to install WinGet. This is a new package manager for Windows, very handy. So you can install WinGet to get these packages, or you can install them, manually yourself using other mechanisms. It's up to you. It tells you to go ahead and use WinGet to install Git, to install PowerShell, and to install Terraform. So I have all three of those things installed. So let's go take a look at that. So first thing here is we're using PowerShell 7.4.1, not Windows PowerShell. That's intentional to make sure that this code is more portable. I'm going to just open up a PowerShell 7 command prompt here. And if we do a winget list, we can see that we have Git installed. And Git for Windows. We have PowerShell 7 installed. And we have Terraform installed. Terraform for Windows. Okay. So those three prerequisites are all met. So the next thing is it wants you to open PowerShell 7 as an administrator so that you can install the Azure PowerShell module. That's already installed on my system, so I'm going to skip that. But you do need to be running that in administrator mode to install that. So we'll move right to cloning the repository that has the Azure Sandbox in it and has this particular sample in it. So we're going to do a git clone using our command prompt. So I'll do a git clone HTTPS. I think that's right. Yep. There's my git clone command. And it brings down the Azure Sandbox repo onto my machine. So that worked pretty good. And now that we've done that, we're going to change down into the directory where this sample exists, just to make sure that we're running from the right place. So I'll do a cd Azure Sandbox, and we'll change all the way down into extras, Terraform Azure RM VM DevOps. That's where we want to be. And we'll launch VS Code directly from this directory with a code space dot. And now we're going to do everything else from VS Code. Okay. So next, we need to set an environment variable. to our service principal. So this is very similar to what we do for the other configurations. So the idea here is to not have um, uh, uh, any secrets stored in your code, but to so we're just going to put this in the environment so it doesn't get checked into source control. So I'll go ahead and set up this secret. So we'll open up a PowerShell command prompt from inside VS Code. And we'll go ahead and set that environment variable. So I'm just going to pause here while I go and get that from my source, from my password manager. Okay, so I've got my secret, so I'll go ahead and paste it in here. I'll have to remember to change that after I publish this video to stop any enterprising hackers from getting into my service principal. All right, so that's good to go. And now what we're going to do is we're going to go ahead and we're going to run Bootstrap. But before we do that, in this previous step here, it says that we need to set up a JSON configuration file. Okay, so this is another difference with this configuration. For my other configurations, I just interactively prompt for the variables for the configuration. But in this case, I've decided instead to just pass it a file with all those default values for all the configuration variables. So we're going to need to create a JSON configuration file to set up all those variables, right? So what I'm going to do is navigate to a different section of the document because I have actually a sample JSON configuration file down here in the documentation section for the Bootstrap script. And here it is. So I'm just going to hover over this. I'm going to copy this. And then we're going to go and create this JSON file. We want to create it in the same directory here as the Bootstrap file, where we cloned this specific configuration. So I'll just click on New File, and we'll call this. We'll just call it bootstrap.json, and we'll paste this in. Okay, so now we have to go fill this thing out. All right. So we'll just go step by step and fill each of these things out so you know where to go get them. So the first thing that I'm going to do is go into the Azure portal and get my Azure Active Directory tenant ID. And it's actually the Microsoft Entra ID tenant ID. So I go into Entra ID, and there's my tenant ID. I'll grab that, and we'll paste that GUID in here. All right. And probably the second thing that I want to get is my subscription ID, which is listed here. So let's go pull that from the portal as well. So if I go into subscriptions, here's my subscription, and I'm going to copy my subscription ID here. Okay. And we'll paste that in. Next, that subscription ID is actually going to be a part of a couple of these other values. So you can see here for Key Vault, I need to paste that same subscription ID in here. And I also need to paste it in here for the subnet. Okay. I think that's all the places where we use a subscription ID. My domain name, since I'm using the Azure Sandbox, is mysandbox.local. You can change that to your own domain name. The admin password secret, since I'm using Azure Sandbox, is admin password. And the admin username secret is admin password, or sorry, admin user. So this is correct for those two. Now, because I'm using this Azure Sandbox, I'm going to use that same username and password for my domain admin. But we do support it being different in this configuration. In my case, it's going to be the same. So I think I left an S out of there. So let's add that. Yep. And I'm just going to copy those secrets down here and use them for the domain admin as well. And we'll grab admin user and use it for the domain admin user. Okay. For the automation account name, we'll go grab that from the portal. So if I go to automation accounts, here's the automation account that got provisioned with the Azure Sandbox. I'll just copy that. And we'll paste that in for our automation account name. And that's where the DSC configuration gets uploaded and compiled. And we also, set some variables up there. Okay, ARM client ID, that's going to be the app ID for my service principal. So I've got that stored in my password manager as well. So let me go grab that real quick and I'll be right back. Okay, I grabbed my the app ID for my service principal, and that goes here. All right, what else do we need? All this stuff is filled out. We need a resource group name. So I'm using the Sandbox, and for this deployment of the Sandbox, I went with the default resource group name, which is rg-sandbox-01. So I'll just copy that, and I'll put that same resource group name in these other two values for the key vault and also for the subnet. Okay. The key vault, I need the key vault name now. Let's minimize this so maybe we can see more of this value. So my key vault name that I deployed with the Sandbox is right here. I'll grab that. Paste that in. Key vault name here. And while we're there, let's go look at that we have the secrets, that we need. So you can see here that I'm using admin password and admin user for both the local and the domain admin for this configuration. If you're using a different domain admin, a username and password, then you'd have to create separate secrets in here. But I'm just going to use the same ones that I provisioned for the Sandbox. Okay. What's next? We need a location. So I provisioned my Sandbox in East US, Azure East US. We need a storage account name. So I'm going to use the same storage account that we provisioned with the Sandbox. You can have your own here if you're not using the Azure Sandbox. We'll grab that. And then we also need to have a container in there called scripts. Now, the Azure Sandbox already has a container called scripts, but if you're not using the Azure Sandbox, you'll need to create that container yourself. So if I go here to containers, you can see here's my scripts container, and I've already used that to provision some custom script extensions for some of the other VMs in the Azure Sandbox, and I'll just reuse that for this configuration. All right. And let's see. Next up is subnet ID. So this is going to need two things that I haven't filled out yet. First is the name of the virtual network. So let's go get that, the virtual network name. Now, since I'm going to use the Azure Sandbox, I'm going to put this in the application virtual network. So there's my application virtual network. So I'll just copy that name out, VNet App 01, and we'll use that for the virtual network. And we're going to use the application subnet, which is the same subnet that we provision our jump boxes in. We'll go ahead and use that same subnet. So that's SNet App 01. So I'll just grab that name and we'll paste it into the name of the subnet. I think I accidentally might have put a return in there. All right, I think all I need to do is backspace that. That looks right. SNet App 01. Okay, that's good. Starting to get dark here. I got to turn my keyboard light on. Okay. So that does it for the subnet ID. We've got our subscription ID is set already. We can just set whatever values we want for these tags. I'll just say we'll call the project Azure Sandbox. And the cost center I'll say is my cost center. And we'll set the environment to dev. All right. The configuration script, we're going to use the one that comes with this repo. You can change this if you want, but I'll just go with this default name here. This sets the size of the data disk that will be attached to each developer VM in gigabytes. So I'll go with the default of 64 gigs here. And this is the name of the DSC configuration that we're going to use to, domain join the developer VM as well as install software on it. I'll go with the default here, the one that's included with the repo. But again, you can change this to a different one if you like. And I'll go with the defaults for the platform image. So the publisher is Microsoft Windows Desktop. The offer is Windows 11. The specific SKU is 22H2 Enterprise that we're going to use for this. And we're going to go with the latest version of that platform image. So I'll just go with all those defaults. And we'll go ahead and deploy 2 developer VMs. And we're going to tell it to start numbering them at 1. So you can start it numbering anywhere from 0 to 999. We'll go with the default license type for the hybrid use benefit. So in this case, it's Windows underscore client. If you're not using the hybrid use benefit, you would set this to none. I'll go with the default prefix for the name of the developer VMs. We'll just say DevOps Win. And we're going to set the operating disk size to 256 gigs. So that's double the space on the OS disk. The default is 128. Now, when we do this, it's the operating system disk is going to show still as 128 gigs, but then there'll be 128 gigs of unallocated space. So we're going to use our custom script extension to extend that partition to use all that unallocated space. So that gives you basically a bigger C drive on your dev VMs. We're going to set the patch mode to automatic by OS. So that's the only thing that's supported on Windows clients, or you could set this to none. The size of VM we're going to use is a standard B2S. That's the default, but you can reconfigure this if you need a bigger VM or a faster VM. And we're going to use standard SSD with locally redundant storage for the disks. So that's it. We've got our JSON file created for Bootstrap. So let's see what we have to do next. So we're going to go back up here into getting started. We've created our JSON configuration file. We've set our environment variable. Now the next thing we have to do is run Bootstrap. Okay. So I'll just do that right within the same terminal we have here in VS Code. I'll do a ./bootstrap.ps1, and I'm going to pass in a parameter with the name of our JSON file that we just created. So that will set the default values for all the variables instead of us being prompted for them. And that makes this something that would be easier to run, say, in a GitHub action or a pipeline if you wanted to execute this configuration in that way. All right, so we're off and running. We've got some checks to make sure that you're running the right versions of PowerShell and the Azure PowerShell module. We read in that JSON configuration file that we just created. We connected up to Azure and validated the subscription in the resource group and the secrets that we created in advance. And we uploaded the custom script extension to our scripts container. And now we're in the process of configuring the automation account for Azure Automation DSC. So we check to make sure that all the modules are there that we need to compile these configurations. Set up an automation variable with our domain name, and we create an automation credential with our domain administrator. And then we import the DSC configuration into Azure Automation, and we compile it. So what you're going to see is we're going to have to compile it once for each VM that we're provisioning. And here we're provisioning, we're doing the compilation for the first of the two developer virtual machines. So I'll be back when this is finished, and we'll talk about what's happening next. Okay, the first DSC configuration was compiled, and now it's going to do the second one. All right, the second compilation is wrapping up. And this will probably complete everything that Bootstrap needs to do. The last thing Bootstrap does is write out a terraform.tfrs file, which it did. So there it is, you can see, and that's all we need to go and apply our Terraform configuration. So we're ready to provision this configuration. So we'll do our Terraform operations at this point. I'll do a Terraform init. This just uses one provider, the Azure RM provider. We can validate the configuration to make sure it's syntactically correct. And we can also create a plan to see what will be provisioned if we apply this configuration. So we'll be seeing one resource for each VM, one resource for each disk, one resource for each disk attachment, and one resource for each virtual machine extension. So that's 10 in total because I chose 2 VMs. I neglected to mention earlier, if you set the data disk size to 0, it won't create a data disk. And then when we would apply the configuration in that case, we would not see any resources for disks or disk attachments, just for the VMs and the NICs and the VM extensions. So that's kind of what I'm expecting. So I'm going to go ahead and apply this configuration. And off we go. So it's provisioning the NICs first. Terraform figures out all those dependencies. Looks like the NICs are pretty much built. Now it's going to provision the VMs. So 2 NICs, 2 VMs. It does those in parallel. So you can imagine if you have a dozen machines or whatever, it's gonna provision all that stuff in parallel. One of the nice things that Terraform does that you could never do if you were just writing a sequential script to deploy these resources. And you can see here the VMs provision pretty quickly. And now the provisioners are kicking in, which register both of those VMs with Azure Automation DSC. So that's what all those local exec messages are that you're seeing there. And that's going to take quite some time. So it usually takes roughly 20 minutes or so for these VMs to provision. So we'll come back when there's something new and exciting to talk about in this process. All right. One of the 2 VMs finished. The other one's not too far behind. And as soon as both VMs get provisioned, we should start seeing the disks and the disk attachments start provisioning. All right, there goes our second VM, and now our disks and our disk attachments are provisioning. So one disk each for the two VMs and one attachment each for the two disks. And those have gone and been created. And so now that the disks have been provisioned, we push the extensions because the extensions need all the disks to be there to run correctly, since they um, partition and format and initialize the data disks. They actually have to be attached before we can push the extensions. All right, so I was expecting 10 resources to get provisioned, and that's exactly what got provisioned. So we'll pick up in the next video and do a little bit of smoke testing against these developer VMs that we just provisioned. Thanks, everybody.